Well, good morning, good afternoon, good evening, depending on when you're hearing this. What we're trying to do here is we're going to talk about quadratic transformations. So I want to be able to describe the transformations from y equals x squared, and I want you to be able to graph quadratics manually. So how can you come up with an easy way to graph quadratics manually? My big question for you is this. Can you summarize all three lessons? So basically all three sets of notes that we've had on quadratics. Can you kind of combine them all into one thing? So could you be able to find the domain and the range, and could you find how you could like all the different types of like the vertex and upward, downward, axis of symmetry, max, min, those type of things, plus this bit about the transformations. So let's talk about these real quick. The parent function, let's look at this. The parent function of the quadratic quadratic equation is y equals x squared. With y equals x squared, we get a graph that would give us like that parabola shape. Now, what we're going to look at first is what do you do when you have plus or minus c? Okay, so what happens when you add a number or subtract a number? So let's look. So if I were to see y equals x squared on my calculator, I would see a graph something like that. The plus 4, I'll do an orange, and you would see something that would be up 4 units. And the minus 1, notice, is down 1 unit. So here, again, this means up, this means down. Notice it comes after the x squared, so this one would tell me I'm going up 4, while this one goes down 1. Okay, so hopefully that should be pretty easy, and should not be anything that's that difficult. All right, so now let's look at what happens when there's a number in front of the x squared. So about a positive or a negative, ax squared. There's really two situations here. Ignoring the sign, either a is greater than 1 or a is a number between 0 and 1. Okay, so a could be like greater than 1 would be like 2 or 1.5 or 5/4. Between 0 and 1 could be 1/2, 0.3, anything like that. And again, notice I'm saying here without the negatives. Ignore the sign, because the sign means something else. The positive, negative means something else. So here we're just going to worry about just what's the number. Think of it as positive. And then if you've got a negative, we'll talk about that later. Well, let's see if you can tell me what happens here. Let's look at a few examples. So here I'm going to do y equals 2x squared and y equals 1/2 x squared. In yellow, I'm going to do the parent function, y equals x squared. And you can see me plotting the points and creating that. Now in orange, I'm doing 2x squared. And in red, I'm doing the 1/2 x squared. Using the terms narrower and wider. Which color was narrower? Narrower. Yeah, I know, it's kind of a weird word. Just go with it. All right. If you notice there, the narrower one is the orange one. The one that was 2x squared. So when a is a number greater than 1, you should be narrower. If it's between 0 and 1, which like 1/2 is, you get wider. Okay, so if I'm asking you the different types of transformations, you should be able to go, okay, it's got this, and it can be narrower or it's wider than the parent function. Again, this is always in comparison to the, or should be in comparison to the parent function. Y equals x squared. Okay, so again, I told you I'd come back to the negatives. Okay, well, here's the negative. What happens when it's a negative in front of the x squared? Well, what that means is a reflection. Remember, this is when you had that earlier, you were talking about it being downward. Well, downward is another way of saying reflection. So let's show you a couple of examples of that and how you might write that. So here I'm saying there's that. there's the parent function in yellow, y equals x squared. And in red, I've done y equals negative x squared, which I would just say the transformation for that was, it was a reflection. It means it went flip down. Okay, now, you can see here that you've got this negative 3. And I'm going to do that one in orange. That one, if I were to list all the transformations, I would say it's a reflection. And the second thing you have to make note of is that it is narrower. Narrower. I'm getting tongue-tied. Just go with that. So you got to make sure that you list like all the possible transformations that there could be. So we could have a reflection, we could have wider or narrower, or we could have shift up and or shift down. Okay, so that covers, I believe, all the different types of transformations that we will see for now. Let's talk about how to graph manually. I'm going to talk about how we can do this with what is called a quadratic slope. Quadratic slope says that from the vertex, you could go up 1 and over 1, up 3 and over 3, and up 5 and over 1. I'm sorry, up 3 and over 1, up 5 and over 1. From each point. For example, let's take this one. There's my vertex, 0, negative 3. I know that because this number tells me to shift down from here, down 3. Okay, the first thing I would do, first quadratic slope, to go up 1, and to the right and left, 1. Okay, you see how I got those points? All I did was went up 1, and then to the right and to the left. Then I would go from those points up 3. 1, 2, 3, and then to the right 1 more, and to the left 1 more. So now you can see I've gone over 3. Now notice here, that's 1 from the vertex. That's 1, 2, 3, 4. Maybe you see a similarity there or something to context. Then from those 2 points, I'm going to go up 5. 1, 2, 3, 4, 5, and then go to the right and left 1 more. Connect all those, and I would have all those points. Now, usually, I think you're good if you just go from the vertex up 1 and then up 3 from those points. But, you know, you can do all of those. That's it. So if you've got a vertex, this should be pretty easy. Okay, now, here I've got negative x squared plus 5, which means I shifted up 5 units, and I'm going downward, or reflecting. It's a reflection. Let's not forget that. Actually, I should say reflection more often. Okay, so I'm starting at positive 5, and I'm going to use my quadratic slope. But this time, because of the negative, I'm going to take this negative and multiply it to the 1, 3, 5, which means I would have negative 1, negative 3, negative 5, which means from that vertex, I'm going to go down 1, and then to the left and to the right 1. Down 3, and to the left and to the right 1 more. And then I could have gone down 5, but I'm not going to do that. That's good enough right there. If you have questions on this, you definitely need to ask, because this is actually something that could be very easy if you just kind of follow along. But make sure you ask questions. Okay, next example. Let's see what happens if I put a number in front of the x squared. Okay, so I'm going to go down 4. I know it's narrower. And then, so I'm going down 4. Now, for the quadratic slope, 1, 3, 5, I'm going to take this 2 and multiply it. So that would give me 2, 6, 10. Now, what does that mean? It means from this vertex, I'm going to go up 2 spots, and to the right and to the left 1. Then from those, I'm going to go up 6, and to the right and to the left 1. So 1, 2, 3, 4, 5, 6, and to the right and left 1. Connect the dots, make my curve, and there you go. That's how easy it can be to graph manually. It's not that hard, really. Now notice here, though, that my zeros are between 1 and 2 and negative 1 and negative 2. So that's probably where the calculator could give us a little bit more accurate answer. Otherwise, I'm kind of guessing and going, I think it's about maybe 1.5, 1.6, 1.7. I'm not sure, but you get the idea. Okay, so let's continue with the manually graphing. Remember, our parent function is y equals x squared, but what happens, like you say in yesterday's worksheet, you were seeing where it was in what is called standard form, where it was ax squared plus bx plus c. So there was numbers in front of the x squared, the x, and the c, a number by itself. Well, we can find the vertex very easily. You don't necessarily need the calculator, although I think the calculator can help it make it is the easiest thing to do. But there is a formula that says negative b over 2a, comma, a function of negative b over 2a can help you find the vertex. Well, what does that mean? Those are just funky letters. I don't understand that. Well, let's see. So let's try for a problem. Here, x squared plus 6x plus 8, which I think was in the worksheet. Negative b over 2a would tell me to put the opposite of a positive 6 would be negative 6 over 2 times 1, because the number in front of the x squared was 1. Well, negative 6 divided by 2 times 1, and 2 times 1 is 2. Negative 6 divided by 2 would give me negative 3. That's your x coordinate of your vertex. So now you're going to put that negative 3 into the x. So I'm going to say negative 3 squared plus 6 times negative 3 plus 8. Quick calculation, you would get that that's negative 1, because negative 3 squared is 9, 9 plus 8 is 17, and 6 times negative 3 is negative 18, so 17 minus 18 is negative 1. So my vertex is at negative 3, negative 1. So I would graph that point and use my quadratic slope to say to go up 1, and then to the left or to the right 1, up 3 from those points, and to the left and to the right 1. And then if I wanted to, I could go up 5 and go from there. So there you go. You could even say that that one represents a shift to the left 3 and down 1. But it would be the same width. It's not narrower or wider. It's just the same because there's no number in front of the x squared to change it. Let's do one more example and then I'm done. I do realize this one's getting a little bit long, but I apologize. There was quite a bit to go over here. Okay, so here I've got a negative 8. Again, negative b means the opposite of that. So I'm going to put plus or positive 8 over 2 times 1, which would be 4. Put that in place of the x, so I'm going to say 4 squared minus 8 times 4 plus 14, which would be 16 plus 14 is 30, minus 32 should be negative 2. So I'm writing all that out, so that's negative 2. So my vertex is at 4, negative 2. Then that would mean I would go ahead and graph that using my quadratic slope. So negative 4, negative 2, and then I could get all those points, 1, 3, 5, make my graph, and there you go. Okay, so that's really how we can do manually graphing. Plus, at the same time, you've also seen how we can describe different transformations. Be prepared to have like a problem that could give you listing all of those. But that is it for now. And if you do have questions, make sure you ask. Thank you very much, and I will see y'all tomorrow.